Let's solve the equation the square root of x plus 1 is equal to 4. You probably can guess the answer by plugging something in place of x, but I would like to come up with a general strategy that we can use on any equation that has a root symbol in it. What we're going to do is, to undo a square root, you can square, and I'm going to square both sides of this equation. So let me copy this down again. I have the square root of x plus 1 is equal to 4, and I'm going to square both sides. If you square a square root, they cancel, and you're left with just x plus 1, the thing that's underneath the square root. If you square 4, well, that's just 16, and you've removed the square root from the question, making it possible to now solve for x. You can subtract 1 from both sides, and we get that x is equal to 15. If I want to just double check to make sure that this is true, I can take that value and plug it into my equation. I think it's going to work out, but just want to double check it. Okay, I get the square root of 16. Is that equal to 4? And, well, 4 is in fact equal to 4, so yes, x equals 15 is a solution. So here's the general strategy. The goal is to get rid of the root symbol. And here, since it's a square root, that means you can square both sides. One thing to look out for is this process can potentially give you what we call extraneous solutions. They look like they're solutions, but when you plug them back into the original equation, the left side will not equal the right side. So let's try that here. Before I even solve this, I know there can't be a solution to the square root of x plus 1 is equal to negative 4. This side is always a positive number. There's no way a positive number could equal a negative 1, but let's try this process anyway. I'll copy down the equation, and I'm going to square both sides. That means I have to square the negative as well. When I do this, I still get x plus 1 on the left, and if you square a negative, it becomes positive, so you still get 16 on the right. To solve for x, you subtract 1, and you get x is equal to 15. But this time, it's not going to work. If you take 15 and put it back into the equation and ask, well, does this thing equal negative 4? The answer is no. One side is a positive 4, the other side is a negative 4. Those two are definitely not the same, so this is not a solution. Here's what this means for us. When using this strategy to solve a root equation and you get an answer, it's possible that it is an extraneous solution. You can plug it back in to see if it works or if it doesn't. The ones that do work we'll keep. Anything that is not a solution, we will throw away. So let's try this idea on a slightly more complicated example, but same idea, where I have the square root of x plus 2. This plus 3 is outside of the square root, and this is equal to x minus 1. What are the possible solutions of this equation? The goal is to square both sides, but I want to get the square root portion by itself first. So I'm going to subtract 3 from both sides of this equation. When I do that, I get the square root of x plus 2 is equal to x minus 4. Now that this piece is completely by itself, I can square this entire side and it will get rid of the square root, but I want to make sure I do the same thing to both sides of this equation. So that is, I'm going to square the left, I'm going to square the right. Let's see what we have. If you square the square root, I'm left with just the x plus 2. And this is equal to x minus 4 squared. And I want to be careful here. If I square x minus 4, this really means x minus 4 times x minus 4. So I'm just going to do that separately off to the side. Okay, this is equal to x times x, which is x squared. I get x times negative 4, which is negative 4x. I get a second negative 4x. But then I have this positive 16 at the very end. If you square the right side, this is equal to x squared minus 8x plus 16. That's what I'm placing right here. So just be careful there. Okay, what happened is we took this equation, solved for the square root, and by squaring both sides, we end up with an equation with no square roots in it. It does have an x squared, but we have a strategy for solving this. We could try to factor it. We could use the quadratic formula. In either of those cases, I want to set one side equal to 0. So what I'm going to do is subtract x and also subtract 2. This gives us 0 is equal to x squared minus 9x plus 14. So if you'd like, you can use the quadratic formula here. There isn't anything wrong with that. But maybe we can think about how this equation factors. Are there two numbers that multiply to a positive 14 yet add to a negative 9? Well, I know it would have to be both negative. That's how you could add to a negative yet multiply to a positive. And let's see, factors of 14, 2 and 7. If I use 2 and 7, I believe that this works. The negative 2 and the negative 7 is a positive 14. The sum of those two numbers is a negative 9. Once I have this factored, I can say, well, if I put 2 in place of x, or if I put 7 in place of x, those are solutions to this equation. The places where each factor is 0. Great, so I have 2 and I have 7. The only thing to look out for is, are either of those extraneous solutions? Do they both work? So I'm just going to check those off to the side. And I'm going to go back to my original equation to do that. So I want to go back up here and say I'm going to plug in 2. I'm going to plug in 7, see if they work. So we're checking 2. That's the square root of 2 plus 2 plus 3. Is that equal to 2 minus 1? Okay, that's the square root of 4 plus 3. Is that equal to 1? The square root of 4 is 2. And this is not going to work. 5 does not equal 1. None of those are equal. So this is an extraneous solution. That's no good. But let's try 7. Does x is equal to 7 work? That's the square root of 7 plus 2 plus 3. Is that equal to 7 minus 1? That's the square root of 9 plus 3. Is that equal to 6? The square root of 9 is 3. And this does. I get 6 is 6. That is in fact a true statement. I have one solution to this equation. It is x is equal to 7. It looked like 2 was a solution, but when I plugged it back into the original equation, it did not work. It was extraneous. And that is it for this problem. The solution is x is equal to 7.